Hello everyone, good evening, happy lunchtime, good morning everyone, wherever you are coming from. Welcome back to yet another stream on the Crosslink channel. Today, we're gonna do we're gonna continue where we left off. That last time, that was Monday, and we are going to continue building our little Voron V0.2r1. And last time we left off where we installed the Z-axis lead screw and that counter nut here. Everything from that perspective seems to be fine, working well. And our next step is going to be building the X-axis assembly. So I'm gonna take a look what we need to do about that. So I want to say hello to Nivas, Police Videos, Xylion, H. Nico, and Lucius. Good evening. So I'm doing great. My week is super busy. I'm currently still busy changing the basement. I have barely finished this corner of the basement where we have the studio and the cameras and basically where I'm recording my videos, but still have plenty of other space that is super messy still. I've got so much stuff there, and we are currently cleaning up and selling stuff, removing things from the basement. So I can eventually move all of the stuff into this room. Also the printers at some point. Still, I have in another room which we're gonna run printers that are printing ABS and materials that require ventilation, since this isn't currently possible in this room here. Yeah, but that's where I am, right? I'm currently still building up the basement and the, if you will, the production facilities for any given future projects. Alexander, hello, welcome to stream. William Harris, welcome. Nice to see you again. A couple people coming on the live stream on YouTube, and also want to say hello to YouTube, want to say hello to our Twitch viewers, and again want to remind the people on YouTube specifically that if you want to participate in the April giveaway, you need to watch any future live stream on Twitch. So you can still watch my content that I'm releasing on YouTube after the fact, for example, recordings of live streams, long form videos, short form videos, that's gonna be on YouTube. But if you want to earn the loyalty points to enter the giveaways, which are called nozzles, you have to watch the stream on Twitch. Explanations are eventually gonna be posted in the chat by our Nightbot, and also by if you look in the, I think it's in the video description, how to join the giveaway. So we were left off with basically this part here where we wanted to build the x-axis, which is going to be this horizontal construction here. This is the section that we are going to build, and we still have to do a couple of heatsink inserts into the x-axis XY joints. That's the connecting pieces that are going to be mounted to the end of the extrusion that is running the x-axis. We also have to grease the linear rail for the x-axis. And we're going to start assembling stuff right now. And I will have to prepare the heat inserts as a first thing to do. So let's start with that. I need to fetch, I've sorted everything into nice little bags, all of the printed parts for each specific section of the build. So we have the XY joint parts here, little pieces, and next step, or what we're going to do now, is inserting the heat set inserts, or the heat set inserts into these parts, starting hopefully with the right one. Gonna figure out which one that is. That is most likely which one is it? It must be this one actually. So this is the first part that we're gonna do, and there is going to be 2 heat set inserts here. It's gonna go in here, and same for the counterpart on the other side. That's what we need to do. Both sides need that. I think in terms of heat set inserts, that's it for the x-axis. The counter pieces do not require heat set inserts. So let's do that right now. As always, you can post anything that you want to talk about in the chat. Questions you might have, any comments. Happy to hear them. So, soldering iron is heating up. Who else is here? Let me know. I think I missed a subscription on Twitch. Who was it? Let me check. Let's. Let me see. Here we go. Lucius Drake followed me on Twitch. Thank you, Lucius. Thank you also. Is it Ilarn following on Twitch? And it's great to have you. Anything. Ilarn. Anything. Any question? Can I shoot Octoprint? What do you mean by that? Do you want to ask a question about Octoprint? Is that what you want? Then go ahead and ask your question. But let's see if we can answer it while I'm doing the heatset inserts. So first one, we need to get it down a bit. I'm also thinking about whether it makes sense to have another camera from the side, so we can, like, if we are assembling stuff here on the second table, you wanna maybe be able to see that in a little bit more detail. So yeah, that might be worth investigating for another camera perspective for the future. So let's push this one in. Nice and flush. Good. First one done. So I want to push it just enough that it's flush with the surface, but not too much. We don't want to push it more inside the plastic part. Yeah, but I think this is probably good enough. Looks nice and flush. So Alan, you're having some issues with Octoprint, wanna basically get rid of it? I'm not being able to use the print button from Orca to Octoprint gets 4.3 error from Orca to Octoprint. 4.3 error, that probably means that you have an authorization problem. The thing is, Octoprint needs you to use the API key. You need to send, I think this is a setting in Orca Slicer that you need to configure. Basically, it's not too complicated. If you look at Orca Slicer's settings, let's check that out. If you have something that is connected via Octoprint, for example, any kind of printer, maybe for example this one here. There is a connection. There's a button here to set the connection. If you can see this, and usually what you do in Orca Slicer is you set the IP address, but then you also need an API key password. And that's something that you can get from the Octoprint settings. So you can go to the Octoprint web URL and log in, and then go to the settings page, copy the API key. That's a section, and copy that API key and paste it into this field here. That should resolve the 403 problem for you. I'm not using an API key because on my printer, in this specific case, we have Clipper running, and Clipper does not have an API key by default, but you can also do that. In this case, you should copy paste the API key. Great stuff. Probably get the Sovol 008. I was asking Sovol if they have a spare test device. They don't have, unfortunately, and they didn't plan to send more. But I'm definitely interested in this printer. So the Sovol SV08 looks like kind of a mixture of a Voron without the enclosure and a bamboo and like something in the middle. I've just seen a stream yesterday on another channel where he was building the printer and assembling it. It's probably a little bit more work than the other Sovol printers. Has more individual parts to assemble, but for about an hour or something, I think it should be doable. So yeah, I'm interested. The hammer is here. Yeah, Jitim Carmen received his package finally from the giveaway. I think it was somewhere in March when we did this. It took a while to arrive. So let's have a quick look where we are with the build. So I have done these two heat set inserts. Now I need to find the right M325s for the assembly. Hopefully it is still the standard. Yeah, this is the standard bag. Everything in this kit is nicely sorted into these little bags. Really appreciate that. We also have one of these little bearings here. Very tiny actually. So we're gonna assemble now the joints. I'm starting with the left joint, which should be here, and we're gonna go to the overhead in a second. We're gonna see more what's happening, hopefully. Great. Okay, so I think this time automatic ISO is working. So what do we need? We need 1, 2, 3, 4 of these little bearings. We need 2 M325s. We also need 2 spacers and a couple of shims, washers. How many? 2, 4, 6, and 8. And then we're starting to put this stuff together. That's a little bit tedious sometimes because let me orient this correctly. First of all, you need to make sure that you have the right orientation of this part. Hope this is the right one. Yeah, it should be. It should actually be this. These are the 2 counterpart. So let me see. This is the one that we're using now, the X-axis joint. They've basically turned it upside down, starting this way. Interesting is that in this drawing, this is the side I'm starting off. Sorry. Yeah, this is the piece that we need. This is the counterpart, and this is the second part. Both pieces are coming together. Let's see how this is coming together in the end. Figuring that out. I think we'll be coming together like this. It's a bit weird. Okay, we're gonna figure that out. we're gonna eventually understand how this works. So this is how we start. We need 2 screws in here. Okay. It's good that the holes are a little bit smaller, because on the other parts it was very tedious that the screws would always fall out, because now we're turning this part upside down and we need to work in this way. We need to work in this orientation and we need to put everything on, and in the other parts the holes were a little bit too big and then the screws would always fall out, so I had to secure them from the other side with tape. I think this is not necessary here. So let's start with the first one. We use 2 shims here on this left one, and then we have a bearing. The second one in the opposite direction, we have another 2 shims. Come on, number 1, number 2. SV06, SV08 looks like a solid option for a lot of people. Yeah, absolutely. I'm curious. Probably they since they want to make this open source, they probably used a lot of Voron base parts, and wouldn't be surprised about that, because if I look also on the hot end or on the Toolhead, looks very much like a mini stealth burner, kind of modified stealth burner. I wouldn't be too sad about this. Honestly, I'm not the person who says, yeah, you cannot use open source parts for a commercial printer. Actually, I would be more happy if they would be using, for example, I've written them actually on Twitter. I've posted them a message that I would actually prefer if Servo would use the E3D Revo hot end. So we have a standard nozzle and a standard hot end on this new printer, and we're not getting something like a new hot end and again a new nozzle design and stuff that isn't compatible with anything existing on the market. Good. Let's continue. We are putting this together now. Our part comes on top. Now I get to understand how this looks like. Okay, and we're using another screw to finally assemble that. Okay, so we're putting this together. We'll probably have to tighten those screws. Let me see, where's my screwdrivers in a new place. I'm curious, does this work? Probably not. Not so sure. For me, it looks like the distance is a little too much, but strange. It might actually be that the threaded inserts aren't completely or not enough pushed in. That's a theory, because they are pretty far away from the screw. Not sure if this is enough to have an M325. Maybe the screws are too short, or the heatset inserts need to be inserted a tiny bit more. So I'm gonna try that on one of the parts. Maybe we didn't push them enough. It could be, if I'm looking from the opposite side, that there's a little gap here between the heatset inserts and the end of the part, but that could also be around about 1 millimeter of gap here. So we can push it further in That's not in the, it's not really explained. It's not really written in the manual here that we need to push them more. On another page of previous installation that we did, on another previous part, there was actually explicitly mentioned that we need to push the heated inserts further in. So that is maybe missing here. And I'm trying to push it another millimeter into the part. So we have the screw grabbing. I think that looks better. We have a millimeter more to push it in before we hit some resistance here. And now it is a bit further in. You can see this. Let's see if this works now. Need to have it cooling down first. Otherwise, we might pull it out. Quickly cool it. And now we can try again if our screws are grabbing the threads. Looks better now. It's probably just the 1 millimeter that was missing. Yeah, from this side here where the screws are visible now, they are actually going a little bit further into the heatset insert. And that should be just enough so everything stays in place and stays together. Okay, was there anything else mentioned here? We also need a self-tapping screw. It's probably another way to secure this together, so things are not coming apart eventually. Great. So the first piece is done. This is one of the X-axis joints. The extrusion will go in here. I'm going to secure it in place in a second. That's going to be mounted on one end. And we're doing the same thing reversed on the other side here. So with the two heatset inserts, we need to push them in further now. Again. Tiny bit more. So this should be good. Probably this was a little bit too much on that one side, but nothing to worry about. Okay, great. Let's get everything on the table again. Need 8 washers. One more. We need one self-tapping screw. We have our bearings and precisely the amount that we need, nothing more. So we cannot lose any one of them. So we're going to do the same thing again. just reversed. Now looking at it from this side, we have a spacer here. The SV08, why would I want to earn nozzle points? Bogey down. Okay, if you are watching this from Twitch, you will basically every 10 minutes you will get 5 nozzle loyalty points. You don't have to do anything more than watching on Twitch. Then at the end of the month, we are going to have another live stream where we are giving everyone the signal. Now it's time. If you didn't do it yet, you can do it anytime, basically, anytime during the month. Also now, you can go on Twitch and send the ticket max command to enter into the giveaway. So basically what you're doing with that is you're spending your nozzles, your loyalty points, for the current giveaway. And the current giveaway is shown to you if you send this command here. It only works on Twitch. Don't forget, you say !giveaway as Xylion did it. You were gonna get a message on Twitch about the link that gives you information about what is the current giveaway. And if you then say ticket max, for example, maybe someone can do it because I don't want to do it. I don't want to participate myself. Then you can participate in the giveaway. That are the rules. And if you want to do it, you need to just hop over to Twitch and watch from there. I understand if you don't want to do that. If you want to say, I don't want to register on Twitch, I don't want another account, that's okay. Of course, it's up to you if you want to do this, but it's the only way how to enter the giveaways. Great. Things are coming together. Just want to make sure we have... oh, come on, what's going on? Why is the screw not going in here? I'm wondering. Maybe I pushed the threaded insert into a little bit too much. We can probably open up this hole a bit more. Okay, it should work now. We could also use the self-tapping screw first to hold the stuff in place. It's also an option. But eventually, no, it's not really that best choice to do this first. I would actually try to get the main screws in first. Oh, now things are falling apart. That's the problem. You turn things upside down. So let's try this again. Why is the... Here, this one is working. This one is a little, the hole is a little bit too large. No, it's too small, not too large. But we're gonna try, Let's secure this one at least. Why is this always falling apart? This is not good. It's not good. First one went so well, and the second one now giving us trouble. Definitely think that maybe we need to widen up this a little bit more. I pushed the threaded insert a bit too much into the plastic, and now we have a little bit of plastic bulging here, and maybe the screw cannot go in. Probably need another screw to test this out. Let's try. If this is a little too small, yeah, that's probably the problem here. Need to widen this up a little bit. So we get it in. Let's do it from the other side. Come on. Okay, that looks better. Yeah, there's a tiny bit of plastic sticking out now, but I guess now we could be doing this. Yeah, this could work. Still it's a little bit more resistance than we want, but I think we have a flush surface here. We can still try, and we can try again. Shouldn't turn this upside down, however. So let's try it. Not turning it over. Are you going in? Yes. Okay, I think now nothing will fall apart. Great. Let's secure these ones a bit more. I think it's a little bit too loose. Good. Then we have this final tapping screw here, self-tapping one that we need. You need to print a small vise. Yeah, that might be a good option here. A 3D printed vise for holding things together. Why not? Sounds so complicated. Well, it's actually easy. It really takes a long time to build this, especially on camera and all of us distracting. Of course. The blue flush cutters, yeah. Everyone has these. They come with every 3D printer in the world. Someone has a monopoly on making these. Okay. Great. Famous, yeah. Famous campus, yeah. Okay, I was thinking that would be kind of a company name that you were mentioning there. Okay, let's see. We have this step done. We assembled both joints. And now we need our X-axis extrusion, the A extrusion. And I'm wondering, I think we have one of these rails left somewhere. Biggest problem might be here to find this. Here we have it. This is this nut bar that we need. So we have a little nut bar, which is basically inserted in an extrusion. Question is is there any of those extrusions here? I think none of them is drilled anymore. These are only plain extrusions, same length, so it doesn't really matter which one we pick now. So what we do is we push this nut bar into the extrusion. Nut bar. Nice. And then we need our little linear rail. Now what we did not yet do with this specific linear rail is a little bit of a different, it looks different. I think it's a brand, what's the brand? Hyven. So this hasn't been greased yet. I'm gonna use our special. Oh my goodness. I managed to kick my screwdrivers out of their place. Why? So maybe I need to increase the distance here a bit. Okay, one is missing. Probably somewhere here. There's my screwdriver. Okay, I'm gonna find it. So we need the lithium grease. Good. So let's put this here into the little slot. That's of course too much, but first of all we want to make sure that we get it in between the rail and the moving slider. And we do this twice, just to be sure we have enough grease in. Okay, let's do it another time. A little bit less maybe. Okay. Here we go. I think this is good enough. Okay. Screwdrivers, we need them on the wall, exactly. So let's put this away, but I want to find one of the screwdrivers I'm missing now, because the Voron mount isn't that nicely secured. Wondering where I can find it. Is it on the floor? Good question. Let's hope we don't need it later. But yeah, we'll eventually find that. We're gonna find it when we don't need it anymore, as always. So we have this little extrusion here and our linear rail. Now I previously inserted these two little screws just for the purpose of securing the slider so it doesn't have a chance to come off the rail, because this doesn't come for any kind of stoppers. There was plastic stoppers on the other rails. For this one we didn't have those. So now we need to be super careful that we don't push this off. In the instruction, we're basically just securing this to the nut bar. Position is not yet final. We're gonna have chances to move this to the final position. What kind of screws do we need? M2 by 6. Let's find them. M2, 10, M3, M3, M2, 6. There we go. Probably just enough to fix this. Is there maybe more? Yeah, there's another bag. More of those. If we have not enough, not a problem. So let's find the first one. And there's actually a helper tool here to hold this in place. Makes it a little easier to align. Still we need to find the first hole here. Get it right. Probably not grabbing yet. Why? Is it not grabbing that hole? Ah, it's M2.5.6. Okay, maybe we did fetch the wrong. Interesting. 2.5 is also here. Didn't get the right ones. So they are a little bit too thick. They're just fitting through, still fitting through this the linear rail, but they're not fitting into these threads of the nut bar. Interesting enough. So this is the right back. They look very similar. Okay, these are definitely smaller. Get in. So this looks better now. We don't want to completely fix them yet because we need to measure the distances before we can do that. Just doing this very slightly. Just a tiny bit. The next print should be Miami Vice. Oh my goodness. Okay, couple more to go. So don't want to push off this rail very carefully. Could be tempted to move it too far and then it's coming off, and then you might lose the little tiny balls that are here inside there, and they might just fall out. That's super critical not to do that. So let's do these last one. So we can still move it, hopefully. Unless I have tightened them too much. Maybe I did. Okay, now we can move it just a tiny bit, just barely enough. Okay, let's find the right position. And we also need to preload nuts from the side. As always, for preloading the square nuts, we're using these helper printouts. These are no drop nuts, and they help us that, first of all, the square nuts don't fall out of the extrusion, and they are also aligned in a way that we can also screw in easier. Where's my square nuts? Here we go. Still have a couple of them prepared already. So we're using the square nuts, pushing them into these no drop nut holders, or whatever you might call it. And then we push it into the extrusion. And now the nuts are in a perfect position, just held in place, not falling out, and also not being too distant from the surface here, from this top surface, so you can reach it with the screw. Otherwise you would have to tilt it over and push the nut towards the front so you can reach it with the screws. So we have two on each side pushed in as per the manual. What else do we have to do? We pushed in the nut bar, used all of the screws. There's less screws actually on the nut bar required because the nut bar doesn't have that many holes. Now we need to make sure that we have exactly 25 millimeters of distance from one of the sides. So using the caliper again. Still didn't swap out the battery, so it's still probably hard to see this. And the camera anyways always has problems picking up an LCD display, so you have to trust me. It's the hardest part to really hit the spot where we have the perfect distance. Does it work? Yeah. That could be a little bit easier. But it's also, these types of distances in the manual are kind of, you have to have it almost perfect. It doesn't have to be 100% perfect. It's more like you should have as close enough as you can the distance that's described. If you're off by, I don't know, tenths of a millimeter, that's not that great of a deal. So we should be fine with this. Yeah, it looks good enough to me. Maybe I did a tad more. Yeah, but it's great. Okay, so we can fix that in place now. Use the depth pin. Yeah, that's this one. It works fine. So about this, we should be good with the step. Now it's time to preload another couple nuts. So we have to turn it sideways and reload 2 additional nuts to this. I think this is then the lower side, actually. Okay. And now it's time to bring it all together. So which parts do we need? We need these extrusions, these pieces to be aligned this way, so it's pointing, the rail is pointing up. We have this fin looking downwards, and now we see why we need the drop nuts here. We have to align them. The easiest way to do this is to first push through with this little hex driver, find the drop nut. Yeah, that is good. And we fix the first 2 screws in position. We need M3x12. M312 machine screws. Yeah, that's the right ones. Pushing the first one in, and hopefully we have getting it into the drop nut. Yes, did work. Second one probably easier now. Nice. So this side cannot fall out anymore. This one is the one that's left. still push it over. Let's wiggle this into position. Is it? Not yet, not quite. Yeah, that's good. Ah, I get what you mean. The depth pin, that's on the other side. Yeah. I always forget about that. Always, probably not rarely use it. Okay, so now nothing can happen to this rail anymore. It won't be able to leave the rail, the slider. Okay, what's next? We've done this, and we also need to do another one from the bottom. That's why we did the 2 drop nuts here. So we're gonna push them under. And we need different screws. We need M36. M36. Here we go. Okay, so pushing this one into the place. Great. This is definitely way more complicated than the V100 build. Absolutely yes. 100%. This is a couple more times complicated, I would say. So many steps. The manual has, I don't know, 250 plus pages to do this, and there's a lot more little parts involved. Of course, this is all more rigid and way less plastic parts. The amount of plastic parts on this printer is really very much from a weight perspective quite low. Most of the parts is the aluminum extrusions and some, if the mat bound, for example, is completely made from aluminum. The panels, of course, are not 3D printed, so most of the stuff with this printer is not 3D printed, I would say, from just a mass perspective. Will it print a better hammer? Maybe yes. Maybe yes. Okay, so this step here, let's double check. Check your work, okay? Let's double check from the side. Looks great because we have our, everything seems to be lined up correctly. Looks good. Double checking if the orientations of the place of the pieces are good, but I think it's good. The distance pieces are in the right position. Side view. Yes, this is how it looks from the side. This is how it looks from the other side. It's definitely looking like in the manual. That's great. We don't need end stops, and now we are pushing this on the rails. We're gonna have a moving x-axis in a couple of seconds, I guess. I'm excited. Really, really excited. So let's get this. Let's get this. Here we have our sliders. And we have our X bar. And I'm curious. There's quite a gap actually. So, yeah, probably we have to release. I don't know if we need to. Do we need to release those nuts a bit here in these screws so we can push it outwards? There's a kind of a little gap here between the sliders and the plastic parts. So I would say 0.5 millimeter on each side. So probably we need to release that a little bit and push it outwards so it's touching, but we're gonna do that if it's required. Let's see if it's in the manual. So yes, exactly, spread them outwards. So with that, we are also using M26, same small ones that we also used for bars. Let me see where I have them. M26. Here is another bag of M26 screws. So let's do exactly that. So let's release them a bit. Just a tiny bit, so we have less friction here, and we can push them, say, equally out. So not too much, but equally. So the gap here is the same. Is it the same? Probably yes. So let's fix this first here with 4 little screws on each side, and then we can tighten that up again. And it's actually beginning to look like a 3D printer, which is really awesome. Can't wait to see this printing. And we should definitely compare the results with the Z100 in terms of speed and quality of prints, because these are very comparable in terms of the size. I mean, this one is still a little bit smaller than the D100. The Z100 has a 150 millimeter squared build volume, or cubical build volume, and this one here has, I think, 120 millimeters, so a little bit smaller. Where's this going? Did I hit it? Yeah. Okay. Okay, so this side is mostly done, I'd say. The other side is still to do. Last 3 ones. Okay. Any questions in the chat? What's chat doing? It'll print a faster hammer. Let's see if that is really true. It's the baby printer series. Yeah, we're doing very small printers. That's true. The second baby printer. But to be honest, I guess this is also going to be, for the foreseeable future, the last. Well, maybe not. Maybe we're gonna see another baby printer soon. Okay, so I think we have it in a good position now. We should just make this centered running smoothly, I would say. Now I will fix this X bar in place. Is there any tension? I feel there's a little tension, I guess. I should probably keep the outer ones a little loose and do the lowers first. Maybe that's gonna help. Okay, that's better. I still think it could be, and it was just a bit better when it was not tightened up. I'm wondering why this is. Is there any tension? Let's release it again. I felt it was running easier when we didn't tighten up the screws. Why is that? Yeah, this is still moving a bit. Question is, can we probably get it straight? We're pushing it to one side. Carefully starting, tightening up the screws. Not too much. Okay, that looks better now. That creates definitely a bit more tension once we do this here. Maybe it kind of tilts inside somewhat, or outside, just a tiny bit. That's absolutely possible. So I don't want to overdo it, maybe. Okay, this feels a bit better now than before. It still feels like it's a little more resistance than when the screws were still loose here. It's a bit strange, but I think still the motor should be pushing that. Let's double check. 1000mm cube build volume. Oh my goodness. Oh my goodness. I would, yeah, maybe we could print chairs with this. A bigger printer. Squaring the gantry, yeah, that's exactly what we did. We moved it way back, we tightened the screws. Check for smooth motion front to back. You should be able to push firmly and the x-axis will move the full travel on its own. Push firmly and will move, not get stuck in the middle of the rails. If not, you need to continue de-racking. You need the y-axis to be perfectly parallel to each other and not angled inward or outward at the front. Okay, so we need to double check with this. I think this is too tight. If you ask me, this is not good enough. So, let's see. I had this feeling. It is not moving as easy as I would love to. Maybe we also can grease it a bit more. But just a theory. So what happens if we push it? It's not as, I wish it would be a bit easier. So maybe a little more grease here. Maybe if we didn't have enough there yet, but it's also critical not to do too much here. Both sides. That's very little. Oh yeah. That's better. Feels better now. Okay, so the only thing left is that we need to make sure that we're not putting this into a tangent angle somewhat. So let's try this one more time. So we'll carefully start with 2. Still feels the same. Just maybe do the lower ones. Now it's much more tension. Now, why? It seems to be pushing the... That's easier now. But as soon as I tighten the lower screws, it is definitely moving a lot less easy. The smoothness is gone. Still moving quite smoothly, but it's still like it doesn't really run to the end of the rail when you push it, right? That's different now. Crazy. Why is this changing so much in terms of the ease of movement? Okay, another theory. Going to reuse the screws one more time here. Pushing this to the very end. I'm trying to figure out where is the frame maybe the problem. Let's try it first on this end. Okay. Sorry that guys that I'm not interacting with you so much in chat. I'm trying to focus here because it's, for me this part is super critical to finish in a good way, because we want this printer to be printing quickly and we want this, specifically this rail, to be moving with as little resistance as possible, and that's currently not perfect. I would say not perfect. It could be a little better. And I'm not trying to understand why this is so different now. So maybe one of these. This is still. I mean, all of them are the screws that hold this against the linear rail sliders. Basically, all of them are tightened up pretty well. I think that's not it. Okay, for some reason we are introducing some tension here by tensioning those screws here. Now this one is actually the worst. I think now it's still moving nicely, but this one, if I tighten up this specific screw here, it really gets under a lot of tension, if I'm not wrong. Why is this happening? Okay, let's do another strategy. Let's loosen up these top ones again. Start with the lower one first. Yeah, there's definitely more tension now. Much easier without the lower screw. I'm sure that this printer would also work just with the top screws tightened. Probably we want to do that. So everything is tightened up now, and we do the lower one not as much as we would probably have to do. Hope that is good enough. Okay, should probably be moving faster. Loosen the lower rail a bit, then slide to one side, tighten that side, then do the same with the other side. The lower rail a bit, then slide to one side and tighten that side, then to do the same with the other side. Loosen the lower rail a bit. You mean the whole rail? Okay, maybe the gantry slide on. You mean I should release these rail screws a bit that hold it against the nut bar? Okay, maybe that's the cause. Can try that. It's a good idea. Maybe it's not perfectly centered for some reason. What's going on with the screwdriver? It's not coming out. Okay. Yeah, let's try that. Maybe that is. You might be right. Maybe we'll just move to this end. Move to that end. Almost, at least, so we can reach the little screw here. Feels a bit better now. Oh man, that screw might be... The ball head driver might not be the best tool for this. Let's do the same on the other side. Okay. Okay, that feels better. Feels like it's moving easier. Definitely moving easier now. At least that made it a tiny bit better, I guess. A little bit, I would say. It's still not, like if you push it, it's not moving completely to the other end. Should probably be. Maybe we do this again. Try to figure if there's any maybe the frame is the issue. Maybe there's something not square with the frame. Let's figure out if we can make it better. I think this is possible. Now, a bit better, easier. Okay. making some progress, I guess. Yeah, I think spending more time on this is definitely the right thing. It's gonna be helpful for everything that comes later. I think it's now a lot easier than before. Both sides at the same time. Okay, should we try that? I think it's like every time I release all of these screws, it feels a lot less friction. And then when I retighten it, it's back to previous state. Maybe do all of the screws and release everything a little bit. But yeah, let's try first to align the position. This I think is the vertical position of those bars. Okay, so now I think this is where we want to be at the end, right? We want to have something that's super smooth. Okay, so let's start here at this end and do the counter sides here, each side independently or together, if you will. So let's try again. Let's do this side here. Use this one. Not too much, maybe, just starting a little bit with tension. Yeah, I think it's better. I think it's definitely smoother. Still not perfect. I think what we now have is maybe a problem with the distance, right, with the parts pushing in. We can then now, I think we can now improve that even further. To release the X-Gantry screws here, and then we can hopefully make it finalize that. Wrong. Okay. Okay, I definitely think it's better. So let's release those here. I think this is... Now we should not have a vertical alignment problem. The only thing is now the horizontal distance is maybe the thing left. Again, much easier now. So let's tighten one. Two. Okay, it's still good. This one here, maybe the printed part is also the issue. Maybe the 3D printed part is just a tiny bit under tension. And let's do the following. We're gonna release the screws that are pushing these parts together just a tiny bit. They can't fall out. Not sure. Definitely think it's easier. It's moving easier now. Okay, we'll have to see later. I guess we did the best that we can. Yeah. It's fairly smooth, but it could be a bit better. My feeling is that one problem might be that the 3D printed part is maybe it warped a tiny bit. And the warped part might be, as long as you don't tighten the screws too much, that's not a problem. But as soon as you do it more, you're starting to bend the part into the like desired position, and then it starts becoming an issue because everything starts warping or starts bending, and that might be a problem. That's just a feeling. I might be wrong, but maybe these parts need to be reprinted, or I don't know. Okay, I think this is actually not too bad. It's actually moving very easily. It's very smoothly. Good. Great, great, great. I think we're making progress. So we have done this step, and I think we have done the best that we can to make this move smoothly. Full range of motion, exactly. And then we have the top bars that are going to be holding the frame, or pushing, I think probably making it a little bit more stable. Because, I mean, actually nothing can move at the moment, so that's probably the top head is also to be mounted to, on this. So we are preloading 3 M3 nuts into these extrusions. We need 2 extrusions. Let's move forward. So it's 6 total. So let's preload nuts. Tutankhamun is to blame for the problem. Okay. Let's see what he says. If he agrees. It's always the fault of the moderators if something fails in the studio. Oh my goodness. Okay, one last no drop nut. And we're done with this one. So now we want to have them aligned in the right place. So we have them pointing outwards this way. That's where they go. How do we secure them? Okay, I see, we have these idler locks. This is 2 plastic pieces that are currently in the front idlers, or in the idler pieces here. We have to take them out. Why did we insert them then? I'm wondering. Now I have to take them out. Probably just for sake of doing it. Okay, and we're going to insert M3 by 10 screws. Where are they? Searching. Here we go. M3 by 10. So we're pushing in, starting on the left hand side, we're pushing it in and we're aligning the extrusion, all extrusions are drilled, tapped in the middle, in the center. So we're fixing this in place. Here we go. You see, there is a tiny bit of tension here. Tiny bit of tension. So it could absolutely be that the ABS did actually warp a little bit. And that might be the reason why. Get it in, come on, why are you not getting in? I'm not hitting this. Why? Should we maybe release the other side a bit? What is happening? What is happening? Too much tension here? No. But there is, I mean, I can definitely confirm that the plastic parts are probably a tiny bit under tension. And that might be, the reason might be that they have a tiny bit of warping. Just a bit. Okay. So. Opposite side, same game, same. Let's do this later, tighten, and this one looks a bit better. Less tension. You're busy looking at the big tree type pie. Okay. Why is the screw not going in? Don't want to overdo this. Honestly. Let's take another one. I hope that the thread in the extrusion is done correctly. Yeah, it's not really going in as easy as I would like it to be, but we can, it's just a tiny bit more resistance here. Still working. The ball head screwdriver is sometimes not the best tool for this if you need a little more force. Okay. This looks pretty good. The nuts are on the outer sides, which is good. Axis moving nicely. What's next? We did this on the other side. We have to push in those, what is it called? Idler cam lock. Okay, idler cam lock. We push them in. We did the screws on the back side. And now we're doing the belts. The belts, my friends. Okay, what do we know? The belt path. Let's check it out. Let's check out the belt path just to get it right. The belt runs goes from here. Okay, this is the drawing is actually not really nicely done. It's overlaying. Why did they draw it this way? You can't really distinguish those two belts. Yeah, okay. This is super. That's the top-down view here is not very helpful. Still, it's probably very similar to what the other printers that I've done so far with Core XY. The principles of Core XY. Yeah, okay, I get it. Let's start with the component preparation. We need the bag here, the Toolhead bag that I have prepared. This is this goes onto the axis on the carriage. This is basically holding our tool head. We still need to do 2 heat set inserts, so let's do that first. Looks very rigid. Yeah, it is. It's definitely more rigid than the V100, but the V100 is also pretty rigid. It's definitely, it's maybe wobbling a little bit more, but it's still a good printer. It's more like for a 3D printed frame. This is actually pretty sturdy. So we're definitely gonna have them running side by side and see what we can do in terms of comparison of performance. So heat it up, hopefully, and start. Let's get those inserts in. Number 1. Number 2. I think that's all, right? You don't have more than 2 here. Yes. Great. The support, I removed that already. We need 2 M3 hex nuts. Wow. It's one of the rare cases where I saw the M3 hex nut actually being used on this printer build. It's not a lot. So they go into this little slot. Get in. Okay, number 1, number 2. So I did the hex nut insertion into the slot. I'm going to push it all the way through to the bottom of the slot. So we can now reach the screws. They are in these 2 little slots here, and so we have the way. Can now use them to screw something on. Probably not gonna come down. Yes. So we have the hex nuts in, we have the heat certs in. Now, what now? How are FHCS measured? Screw lengths are measured from the mounting surface of the bolt. Oh, this is a flathead. Okay, it's flathead screw. M3x8 flathead. Yeah, that's something we need to find now. M3x8 flathead screw. We have found it. We need 2. And we need 2 maker beam T-nuts. XL. T-nut XL. Is this XL? good question. Not sure if there's the bigger ones. My assumption is that these are the ones that we need. If not, I would be... Maybe we can look in the... one of the... Maybe in this little box here for the tool head, maybe there's different ones. Bigger ones. But seems that's not the case. Here we have GT2 belts. We need them. We need them now. That's good. However, I think these are the right XL T-nuts. These little pieces here. Okay, so how should we align them? Okay, we're gonna push through these little flathead screws. And we have it on this side here. Okay, is this the right size? It looks like. They are fitting in here in this little slot. Keep them loose. The belt is threaded into this part. Okay. So how this works, we have these T-nuts here, and I guess that the belts are going underneath, and when we tighten this, it's gonna push and hold the belt in place. Gonna pull them down, basically. Same on the other side. We want to keep them quite loose, obviously. Okay, so it's prepared. What next? The belt length for the X carriage. In one cut, trim the ends of both belts together to get them equal length before you start routing. You will need 1 meter or 23.4078 attoparsecs. Oh my goodness. What is that? Oh my goodness. Yeah, Voron has one with HD printed. However, I heard that you have to be very careful using 3D printed parts, because Voron has specific guidance about what settings to use, and some of these kit manufacturers don't use the right settings. They are kind of saving on the material side. I used exactly the Voron settings with the right amount of parameters, the right amount of infill, bottom and top layers, and that's super crucial if you want to have very rigid parts. Of course, you can reduce those settings and have a more lightweight print, but it's also the risk that you're not having the same sturdiness. So that's why I would be triple checking those parts. If maybe this, like basically breaking a couple of them apart to see what print settings have actually been used, and then you probably have to use, you have to reprint them again. But you never know. Okay, so let's do you will need 1 meter. The question is like, how precise? I mean, we can still use the belt tensioning to fix any kind of misalignment, I guess, but if we need 1 meter precisely, let's try. 1 meter for each belt. How much is this? This is 4 meters. Okay, it's supposed to be 4 meters. Need a really good cutter knife. What was that? What was falling from my table? I have no idea. Oh yeah, this is cover for the cutter knife. Okay. We want to keep that. So, how do we cut this to exactly 1 meter? I have a ruler here on my cutting mat, but it's only 90 centimeters, not exactly 1 meter, so we'll need to be more creative with this. We can use our ruler here, and we want to cut to 1 meter as best as possible, as precise as possible. So let's figure this out. And they wanted us to put them together, if I'm not wrong. Trim the ends of both belts together in one snip. 1 meter for each run. Okay. First belt, second belt. I'd say then we take a little more than 1 meter, maybe, I don't know, 11 or 1 meter and I don't know, a few millimeters, and then we're gonna overlay them and cut them into the perfect length. So we're just gonna roughly cut 1 meter twice, and then we're gonna overlay them so we can have them properly cut. How much do we need? I think this is everything that we need, right? We don't need any other belts. We need that. Okay, so we can probably, we can afford to cut it a tiny bit longer. How much more? Maybe, I don't know, 2 millimeters or something. So now let's first overlay the belts. Okay, so we're gonna put the ends together, overlay them, and then we're gonna make a clean cut here. Just one belt is a tiny bit longer, so we're gonna try to cut them as best to the same length as possible. Snip, snip. Maybe not enough here. Too little. Come on. The knife is not sharp enough. But yeah, this is good. This is good. Yeah, pretty much. It's maybe a half, 1/10 of a millimeter, so we have them both in the same. Now we're gonna measure 1 meter while holding them together. So I'm going to press the belts together so we're not skipping any of the teeth. Come on. And that went wrong. That didn't work. So let's take the short one. So this is the side. 1 meter. Okay, let's have the second one. So roughly, again, do this roughly first. Let's give it a couple millimeters more. Doesn't matter. Okay, and now, come on, stay here with me. So, overlaying them. That's probably the wrong side. Yeah, that's good. So gonna press them together. Come on. This is not going well. This is a bit tedious, honestly. Why is this not working? Stay together. Should I glue you together? Tape you together? What should I do? Okay, could use tape to keep them together. So let's figure out 1 meter. Stretch. That's good. And here we go. Cutting at 1 meter. Exactly here. So, my clipper here. Come on. Clippy, clippy. I don't know how important it is to have exactly 1 meter, but we have 1 meter now. It's now 1 meter. Pretty precisely. So I hope this is good enough. Great. Okay, since we have now 2 belts of the same length, what should we do now? Snip, snip, we did that. We start to insert, thread the ends of the belts through the X carriage like so. A pick tool can be helpful here. Begin tightening the screw on one of the maker beam nuts. What's interesting is that we don't see where the teeth are oriented towards. Is it towards the front or is it towards the back? The motors should be as far to the outside of the printer as they can be. Okay. Let's prepare this. Okay, that's the case. So I'm wondering how they are orienting the belt. Which is the A belt? The A belt is like tying your shoes, but worse. The A belt is the lower belt. It sits below the belt. So question is, are they fixing the carriage already? No. Did they? Did I miss something here? No. That's not mentioned here. We see that the carriage is going to be on here. This is what we've done. Yes, we've done that. It's only talking about running the belts, but it's not yet attached on. Yeah, it's not really attached. Okay, let's start here. Thread the ends of the belts through the X carriage like so. A pick tool can be helpful. My question is really, which way is it oriented? Is it facing to the back? Let's figure this out. We can maybe have a good guess. If we start like this. How is it then going to be? Okay, it's going to be this way. It's going to be pointing back. So I think we have to reverse engineer the belt path from the point of view of the motor. If we have the A belt, if we are starting with the A belt, it needs to be facing into the part, so we are not seeing the teeth from that perspective. Okay, so we are always looking at it from the flat side. Good. Okay, let's push it in. And I'm trying to show you as best as I can what I'm doing. It's probably sometimes you have to decide whether we want to see the manual or if we need to see the printer. I'm currently pushing the belt in here. And where does it want to come out? To the front. Okay, we want to push it in here. I want to have it coming out to the front, and we need some kind of flat tool to push it through this front hole. That's actually tricky. Yeah, as they say, it's probably you need some kind of pliers or something flat to have it coming out to the front. Let's give it a try. I think it's coming out. Okay, here we go. The first one. And then we have the second one. Same way. B belt is the upper one and A belt is the lower. Okay, let's push that one. Let's push it through. So we get it out here. Come on. Almost there. Good. Out to the front. I don't know how much, but yeah, what do we do? Make sure you thread the ends of the belts through the X carriage like so, and the pick tool can be helpful. Begin tightening the screw on one of the maker beam nuts. It is easiest to attach one end of each belt first. Run them through the printer and then thread the other end through the X carriage part, and then beginning the tensioning process. Well, I would say we don't want this to come out. We want to tension this a bit. So things are not moving anymore from that perspective. Okay, so we have A and B belts prepared, but still it's going to be mounted exactly the other way around. Not wrong. Are they starting with only one belt? I don't care. So we can now do the A belt installation. I would say we're starting like this. It's pointing backwards. I'm running the A belt. Where is it going? A belt is the lower belt. Okay, A belt should be running first to the front. So that's probably the hardest part, that we need to make sure that we have the belt always going where we want it to go. Now it needs to be pushed around this corner. Come on. Or we can just have it coming out and then we're pushing it back. Is that working? Not sure. It's not flexible enough. Oh, yes, it's working. Okay, so a belt. Please stay on this pulley. Okay, so this is the first one. And it's the lower belt. And yeah, the tedious part is that this thing is always loose now. It's not gonna stay in place, most likely. So let's keep it in the lower pulley. Then we'll run it around this corner. We run it to the front. We need to go around the motor now. I have no idea how easy that is, how complex. Maybe we just pull it out here to the top and push it back in like that. Need to trick it a bit. So let's try that. Push it through, run it around the motor, push it back here, go back through this hole. Then we need to make sure that we run it around the pulley, yes, and to the back. Back, around the corner, and back in here. So we made a full, oh my goodness, yes, I know. We made a full turn now. And we came out here at the front again. Then we can now try to push the belt. Which one is it? The lower one. So we need to push it through here and get it out of the part, pushing that to the front. That's probably the hardest. Get this also out to the front. Not sure if this is easy enough. Is this even possible? Don't see it, honestly. Probably I just remove this second T-nut here. I'm just gonna take it off. Not sure if this is a good decision, but actually I think if we just go now and push this out to the front first, and that's tight. There's not much room. Now we have it coming out to the front. Now we can reinsert. I think we can also leave it out for now. We do the second belt, and then we reinsert the T-nut here once we have the second belt running around. That's probably the best. Okay, so can probably pull a little bit on this end. And we're running the second belt. We're doing the B belt. Same start here, going around the corner to the front, around the printer, and around the motor pulley. Now let's go. We get it out here. Stay on the upper. Okay, and let's move it back. Going back. Come on. Now I need something to pick it. Okay. Come on. Got it. And coming out and going around this corner and the front, and we're going around this pulley here. Yeah, that's difficult. We need to push it through so it comes out on the right side. My friend, get in. And we're back at the front. One full turn for the B side. So now you can push that also out to the front. So now we have both belts you should have both belts coming out here at the front. And now it's time to reinsert this huge maker beam nut and fix the belts a little bit more. That was the best decision. Okay. So theoretically, everything is in place. So is this thing moving? Belt running nicely. So we also want to make sure we also on all of the desired idlers, and we need to tighten the belts equally. I mean, at least we're trying. I'm going to pull a little bit more out so that we have everything good pre-tension. You see, I did the second belt basically without the manual because I did it already a couple of times. But basically coax-wise, pretty intuitive if you stay on the right height and you following around the pulleys. That's great. Where do the belts tighten? Yeah, let's talk about that. I'm doing a kind of a pre-tightening here at the front. So here is this part where the belts come out, and you can basically tighten these the maker beam nuts, but that's only to hold the belt in the right place, so they're not going out, not escaping. So we're going to do a little bit of a pre-tensioning here. You see, I can still bend this part over. I can still pull, I can release the nut and pull out the belt a tiny bit more to the front until, I mean, we want to have ideally both belt ends, and this is for this side, we have both belts ends out the same length, pretty much the same length, more or less a millimeter, yeah, half a millimeter. This is the same here, so I want to make sure I have these out as best as I can to the same length, and then fix that in place. So ideally both belts are kind of have the same pre-tension now, so there shouldn't be a huge difference. It's not actually the case, not really true, to be honest. It could be a little better. Actually, the lower one seems to be a little more loose, but we have tightened the belts to the same length. So if we just make sure that both ends here are sticking out the same length, we are pretty much, I think we're good. Right. So pulling that a bit more, pulling that a bit more. How are we looking? I think these are now good. These look pretty much the same length. Here we have still a little difference. I want to pull the upper one a bit out by one step. Was maybe a bit too much. I think now it looks good. So we're fixing this now, and I think from a belt length perspective, I have both sides now out the same length. And we have, yeah, some kind of pre-tension, right? And the manual says exactly the same. You want to secure the belts in place, and you want to make sure that they are the same length sticking out. Yeah. Equal tightness by counting the number of belt teeth showing on each free end. You can count the belt teeth. We could do that. But by just overlaying them, I can see that they are equally long. So it's, from my perspective, it's looking great. So we have basically the same length sticking out, and we are securing them. I can double check that I have now the mecha beam nuts are really tight. Nothing is moving anymore. And now what the next step is basically securing this X carriage to the slider. So let's do that. M2 screws is required. M2 screws. Where are they? M2 here we go. So we need 4. Nice, we did have not a single dropped frame until we started, since we started. Excited. Okay, you just center this. Find the place, and now we secure this. X carriage. Basically. Yeah. Stay here, my friend. Don't run away from me. Ooh, okay, pretty tired already. Not sure how much we actually need to do it. Oh, but maybe a little bit more. Okay, so the question that you had, Alexander, how do we tighten the belts? So we did now pre-tighten the belts. Hopefully enough. We can still go back, and we have the feeling that we don't have enough room to tighten the belts with the belt tensioning system. I'm going to show you in a second. We can probably still go back and loosen everything up a little bit and pull out the belts a little bit more. That's why I'm not going to cut them now. So how do we tighten the belts? There is 2 huge thumb screws here. On each motor there is 1, and you see the motors are currently from a position they are as much out as they can be, so they are on the outer end of the frame. What we now are basically doing when we are tightening these thumb screws, we are pulling the motors inwards. this thumb screw is pulling the whole motor and with the pulley into the inside, right? And that is tightening the belts. So we can turn this wheel here, or this screw, and with that we have basically the belt tensioning done. Now what they do, or what you can do, is you can use an instrument tuning app to figure out the sound the belt makes when it's when you pull on it, right? I think I have such an app here. Let me see. Can show it to you. So we have this tuning app here, but we need to be super quiet now to tune it. And I'm gonna hold it as close as I can to the belt, and I'm trying to show you the frequency. Oh, stay here. I'm gonna try to show you the Oh, that sounds good. Maybe a little less. Yeah, if you tighten one side, other side of course gets also a bit stronger. I think this is good enough. 110-ish. Okay. Should probably measure the inner side. Maybe that was one thing we missed. Let's see. That's already too much, is it? Oh, yeah, but too much. We have a little too much, obviously. So let's release it a tiny bit. Okay. But we were almost there. We were a little too much. Okay. Okay, that sounds perfect. Just did it again on the inside. We had a little too much tension for that, but that's great now. What now? Next step is, once we have done the tensioning, we can now fix. Theoretically, we could fix the motors in place. We don't have to, I think. We can keep those motor screws a little bit. Keep it a little loose, but I would just make sure that nothing is wobbling. I'm not sure if we are supposed to tighten the motor holding screws. These are the 4 screws per motor that are holding this whole thing in place. So as soon as you start fixing those 4 motor screws, you wouldn't be able to tighten the belts anymore. So we are measuring on the inside of the gantry, not the outside. That was my mistake, but now it seems good. Can we play 7 Nation Army on it? I think Iron Man. I see. Great idea. Maybe we can make the printer at someday. We can make the motors play sounds. Okay, we have done the belt installation, my friends. I cannot believe that we actually made it this far today. So we assembled the gantry. We did the belt installation. Nice. I mean, this is progress. That theoretically we could already run the motors from the main board and try out what happens very, very soon. What is next in the manual is the print bed installation. So we have, I think we can prepare that at least. See how far we can go, how far we can get today. What is this? I think it is M3x10, is it? There was a spare M3x10 on the table. This is also open. Oh, a couple of screws came out here. Good. Let's see what we can prepare. Du hast, genau. Okay, so we have these 3 little belt, 3 bed leveling knobs, little tiny knobs. We are going to do heat set inserts with those as a first step. Pushing heat sets in. Let me do that. I think I want to do it from the back, so they are pulling in and not pushing. Okay, heating up the soldering iron. So much progress. I'm gonna stream probably a couple more, maybe half an hour or so. I'm gonna continue for the next 30 minutes. So I guess we can install the bed in the next half hour. That should be realistically to do. So first of all, we're gonna insert these little threaded inserts into our knobs. And then let's see what's next. Okay, number one. Number two. And three. Okay, I hope this is good. Let's have it cooling down a bit. Great. Great, great. Heat set inserts. Now, print bed. Let's take out the little build plate. There we have it. Belts we don't need. This is the tool head. There is my print bed. Here we go. Tiny little print bed. Oh, isn't that cute? Isn't that cute? Look at this. I can hold it with my hand. It's just so tiny. So tiny. Really nice, really nice. Okay, so how are we preparing this? How are we preparing? Orientation of the build plate. The side with the single hole is the front. Yes, I get it. I think this is obvious because it's gonna be that way. So, magnetic sheet. Clean the plate with isopropyl alcohol. Isopropyl or similar cleaner, and okay, so we're gonna align the magnetic surface now. And this is a quarter of the normal print pad. Absolutely, it's 120 or something, so it's basically a quarter. Okay. We don't need a guide, right? You don't need to watch a video for that. A bed heater, I think, let me check out if we missed something. We are on page, where are we? Which is the page? 146. 146. Metal thumb screws. 145? What? Give me a second. 145? There's metal thumb screws included? Really? Okay. There is metal thumb screws in the kit. Are you serious? Okay. Honestly, I did not see them. Metal thumb screws. The question would be where to find them. I honestly did not see any metal thumb screws in this kit. But maybe we just have to look a little bit into the rest of the packages. Was maybe not in the main bag with all the main assembly screws, but maybe we have another place where we can find the metal thumb screws. Not sure, honestly. I did not see them. But maybe I just missed out something. Maybe I missed something. Toolhead in motion. There's another little box that there could be something maybe. And we have this electronics box here. But no, there's no metal thumb screws in this. Only thing could be toolhead in motion. Honestly, I do not see anything that comes close to a metal thumb screw, 3 metal thumb screws for the heated bed. So triple, quadruple checking all of the stuff here that's maybe left. No. So we could skip that, but it was, yeah, do manuals working in the other way. Yeah, you are absolutely right. That gives me trouble because you have to be so careful that you're not missing some of the hints from the LDO guide. But guys, this is the page, right? We were on page 145 and he says skip, metal thumb screw are included in the kit. And 145 was preparing the heat bed knobs. Now, if we don't find them, honestly, we have the version from the original Voron kit. We did them, so we're not missing something in a way. We still can assemble the stuff, but I would be happy to have metal thumb screws. Bed springs are here. There's a PCB kit. There is heat pad cables. There is cables. There is another little bag here, standoffs. I can't. No, there is definitely no metal thumb screws in this kit. If you ask me, this is an unsolved mystery of the LDO kit, to be honest. Either I have them where I can't see them, or they are just do not exist, if you ask me. Maybe they missed them here. Or I don't believe that we have those. There is nothing. There is honestly nothing like that. I am pretty sure that I did not throw anything away or something. Definitely not. So yeah, I can go through this one more time, maybe after the fact. but yeah, you have to search long enough and then you're gonna find what you search, right? What is this? M3 by 30. Why is this all out of the bag? Is this open? So where's this bag for the M330s? M325, M330. Here we go. And if you keep searching long enough, then you're gonna find what you're looking for. Metal thumb screws. Okay. We wanna use those? Or do we want to use those? What do you think? What do you think looks better? Let me know. We have both options now. We have options. Metal ones, red ones. Okay, let's do a voting. Everyone say red or metal. What do you like? Red. Red, metal. Okay. Come on, let's go. Okay, red. Metal, metal. Okay, I think it's still a tie, right? Oh, maybe just a little. Yeah, red. Okay, one more vote for red. 1, 2, 3. 1, 2, 3. 4 for red. 4 for red. I'm gonna show it to you again so you can make up your mind. So we have the metal ones here, metal thumb screws for the bed leveling, and this is the ones that we 3D printed. Red would match the print, the build. I don't know about the stability, but I guess they are most probably equally good for terms of stability. I personally would say I go for the red and see if they work good enough, if they work, and if they work fine. Maybe they're actually also easier to grab, but the metal ones could be giving a little more preciseness. I think they could be easier to adjust. Just the tiny adjustments could be easier with the metal. That's maybe the reason why they have changed that, because it's in the end more precise. These little ribs here, for the red ones, they are a little large. It's probably harder to do these little precise. Yeah, let's see. Let's use the red ones first. I think they look just a little bit better. So what do we need for assembly? We want to clean this. Not sure, is there any additional protective film on this? This is, yeah, there's a plastic film. So we are removing the protective film. Then we will clean it. Oh, come on. Come on. So we will also have the magnetic sheet ready. It's here. Separate that. So this is our magnetic pad. I'm wondering whether I think they mentioned in the original manual, or in the manual they mentioned that the magnetic sheet should have holes. I have my doubts because it doesn't have holes. The magnetic sheet doesn't have holes. So I would say we do not do this now. We do not. Let's see. 146 to 148. Skip bed and heater comes pre-assembled. The only thing to do is to fasten the bed thermistor into the center hole on the bottom of the bed. Okay, so we are basically skipping 146 to 148, and we are attaching, what was it? We are attaching the bed thermistor into the center hole on the bottom. So that should, yeah, I was wondering. Still, they are mentioning that the magnetic sheet should be having holes for the screws, which is not the case. So I'm saying we're doing this as the last thing. And we are, this is the sensor cable that goes into the center. So let's attach that now. Do we need to? Okay, that's fixed. So we now have the temperature sensor. These are the electric cables. There's a little fuse here, temperature fuse, which is gonna shut down once it's overheating. Yeah, the hole is probably not needed. But we cannot apply the magnetic surface now. We have to first get the screws in position, I would say. We even mount everything together and then do that part. So we have the cables in place. Thermal fuse is in place. What is next? Any changes here? Page 150. Use M3 lock nuts with the flat side up rather than the M3 hex nut and washer. We recommend using an M330 or M335 screw for the kirigami bed instead of the M340. M330 or M335 for the kirigami bed instead of the M340. M3 lock nuts with the flat side up. Okay, this refers to page 150. Okay, we'll use a little bit shorter screws for this, obviously. Whether we're gonna use M330 or 35, I'm not sure. If we have the choice, I would rather go with the shorter ones. We need 3. So the plan is that we're pushing those screws through from the top and we're securing them with lock nuts. Lock nut M3. Got it here, 3 pieces. And we're not using washers, we're using the flat side. Good, let's do this. Lock nuts means we have to hold them. We cannot do this with the hand. Okay, so we have 1 lock nut and let's get it on. So let's check if M330 is long enough for this, together with the bed screws, bed spring. Let's find out if we have now enough length. So this could be good. It's tight and we have the yellow springs. Well-known yellow springs that we also have. I have them on my Ender 3s now and started, but I actually started to replace all of them with these rubber, thicker rubber pads instead of springs. Yeah, we have a good amount of tension, but still, I guess we can exactly, like, we can use the shorter screws. Just pushing them requires a little more force, but that's okay. I think that's good. So let's get the rest in, the remaining 2 screws. Lol. Okay. I said something funny again. That's my bad German English. Come on. So, we're getting there. It's probably the last thing for today is to get this, the print surface in place, have the springs and the leveling knobs installed. I think after that we're gonna end it. And next week, most likely, or anytime, as soon as possible, basically. As soon as possible, we should be continuing this. I want to get it done. I really want to get it done. Still, we have to do a lot of things in terms of wiring. I will also prepare the software installation. At least I'm going to pre-install the operating system on the Raspberry Pi, pre-installing Clipper, also flashing the main board. I think these are all steps that are probably not that interesting. I mean, interesting. Yeah, they're interesting, but you can't see a lot, right? It's nothing super interesting, at least. Nothing where you can follow along so easily. And yeah, we want to get it done, right? So I want to do as many things between now and the next stream as possible. Of course, if I can make it happen, we're gonna do a live stream for continuing where we left off. Come on. Last one, almost done. Okay, so we're almost there. I guess we can now look in the manual. What is next? What would be the next things to do? Getting it aligned, and then what are they doing here? Installing the link. When do we do the cabling? I'm not sure where doing the cable installation. I think this is somewhere here. Page 152. bed wiring for the heater, thermistor and NeoPixel. Please use our Kirigami bed guide for wiring. So we are basically 152. We're gonna install the screws and the bed springs, and then we're gonna do wiring according to the wiring guide. This is the guide. Okay, so let's first get this down in place. We need the springs. Where does it go exactly? Just want to make sure I'm not squeezing any of the wires in. So let's have the springs in position. Come on. So springs are in position, and now we can start with the first one. Just pushing it down a bit carefully, we're not. And that's already it. Super easy. I see, I guess I know why they have replaced the knobs. The reason is it was actually not so much the diameter or something, but it has a bigger standoff. So I don't know, can you see this? The standoff for the metal knob is a little bit higher. It has more distance from the print bed, so although this looks bigger and easier to grab, it's actually not, because you have to be, it's very, very close to the underside of the Kirigami, and that means you really only have your fingertips to reach, because it's pushing, this is already the flat side, so it's really that much, you only have that much. You see what I mean? So it's not really very easy to do. This one is easier to grab because it has a bigger standoff. You have much more, your fingertips are gonna touch it better from the side. So I guess that's a very good reason to use the metal ones. Although I don't love the color, but I can see that this will definitely, I don't know, it's gonna annoy us a bit in terms of how easy to use it. It's definitely easier now to use that. I can definitely confirm that this is much easier. So let's still use the metal ones, although they don't look as great. Okay, so the last one is here. And that's it. You will burn the fingers and a lot of cursing when adjusting the bed heated at 100. Am I going to do that? I have my doubts, honestly. At 100, probably not so much. Okay, I'm gonna leave it here. Next thing is going to be wiring. That means we're going to, you can't see that unfortunately, but here we could get a glimpse what we do. We have some Vago clips here, and we are going to run the bed power cables to the Vago clips, and then we're gonna come from the main board to the Vago clips, attaching the power here. And the sensor cable will also run, it's going to go, I think it's going to go through the cable chain back to the main board. Here we have here you can see that, you can at least guess what that is. We have two cable chain connectors that we previously mounted. The cable chain is going to make a turn here. It's going to run, I think it's going to go up here and it's going to go down here to the end, and I'm going to route all of the cables out here into underneath the bed to the back side of the printer, where all of the electronics and main board is going to be right here. The cable is going to go down here and then around here. That's how it will look like. Yeah, gonna plug it into the mains. Are you crazy? No, I think I'm not gonna. I wouldn't be that stupid, honestly. Luckily, there's no mains power except the main board, not the main board, except the power supply, and everything else is 24 volts. But yeah. So, it's 12 past. So, midnight just passed by in Germany. So far, it's looking good. I like this. I like this a lot. I think we made significant progress today. Compared to last time, definitely more, but we also had more time, had 1 more hour today. And yeah, let's take a picture for all of you Insta fans to show the progress. Great. I wish you a good rest of the week, and if I get to stream again until before next week, I'll let you know in Discord, and of course you're gonna see the notification popping up. I'm not sure, the weekend is pretty packed, so I guess we're gonna see, probably the earliest is going to be Monday. And then I'm doing in the meanwhile, I will probably do little things in terms of software pre-installation and stuff like that. Maybe some testing to make sure that we have at least a couple of things in place to be, not lose so much time. And with that, I want to say thank you to everyone for coming. Thanks for subscribing on Twitch. Thanks for subscribing on YouTube, of course. Have fun. Have a nice weekend and stay healthy. And we're gonna see each other very soon. Bye bye.